Where does f of x equals e to the x times x squared plus 3x have a horizontal tangent? And we can leave our answers with just x values only. We'll go ahead and try to figure this out and then see if we can verify our answer using our calculator. So we're given a function and we want to know, where does this function have a horizontal tangent? So we need to think first about what we know about a horizontal tangent line. So if a tangent line is horizontal, then that means that it has a slope of 0. So if the slope is 0, that means the derivative is equal to 0. So that tells us we need to compute the derivative of this function. Now notice this function contains a product. We have e to the x times the quantity x squared plus 3x. Therefore, we're going to have to go ahead and use the product rule here to find our derivative. So we have our first function, which is e to the x, times the second function, which is the x squared plus 3x. So the product rule says we're going to take the first function that's being multiplied. In this case, that's the e to the x. And then we're going to multiply it by the derivative of the second function. So in this case, we're looking at the derivative of x squared plus 3x. The derivative of x squared is 2x, and the derivative of 3x is 3. So that's the beginning of our product rule, plus the second function that's being multiplied. So in this case, that's the quantity x squared plus 3x. And now we want to multiply that by the derivative of our first function that was being multiplied, which in this case, the derivative of e to the x is just e to the x. So there we used our product rule. Now let's work to simplify this a bit. And hopefully you notice that we have a greatest common factor of e to the x. So we can factor. Let's factor out an e to the x here. And if we do that, we will be left with 2x plus 3 from the first term times x squared plus 3x from the second term. So we can essentially drop these parentheses that are inside the brackets, and we're just going to simplify 2x plus 3 plus x squared plus 3x. So we have a simplified derivative now, e to the x times x squared plus 5x plus 3. Once we combine like terms. So remember, this derivative represents the slope of the curve at any point, and we're wanting to find where the slope is equal to 0. So that means we are essentially going to be letting the derivative here equal 0. So if we do that, we're going to end up with the equation 0 is equal to e to the x times x squared plus 5x plus 3. So now we need to solve this equation. And you can see this is why it was beneficial that we went ahead and factored it, that this is in factored form. Because if we're going to set this equal to 0, we're going to use that zero product property. That's the fancy term, which basically means we're setting each of these factors equal to 0. So either e to the x equals 0 or x squared plus 5x plus 3 is equal to 0. So we have two separate equations to solve. Let's start off with the e to the x is equal to 0. You can either just think about this and realize that there's not going to be an exponent that makes this true, or you could use your knowledge of logarithms. Remember, e is the base here, so if we were to rewrite this in log form, it would be log base e of 0 is equal to x. In other words, it really is the natural log of 0 is equal to x. And the natural log of 0 is undefined, so we do not get any solutions for e to the x equals 0. There's no x value that will make that true. So then we move over to the quadratic equation, x squared plus 5x plus 3 equals 0. And this is where we really would hope that it would factor, but remember, we don't have any numbers that multiply to 3 and add to 5. So that tells me that this does not factor, so we need to use a different method. And in this case, it's probably easiest to go ahead and do, yes, the quadratic formula. So go ahead and moan and groan for a second, and then let's do the quadratic formula. So x is equal to the opposite of b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. So this is where you just want to be careful. Don't make any little careless computation mistakes. That looks like 25 minus 12. So we're looking at negative 5 plus or minus the square root of 13, all divided by 2. So the question said, where does this function have a horizontal tangent and give x values only? It looks like these are the two exact values. These are the exact x values where the tangent line is horizontal. And of course, if you wanted to go ahead and go to your calculator, go ahead and do that right now, and let's get the decimal approximation. And the approximations look to be about negative 0.697, so negative 0.697, and negative 4.303 if we were to include 3 decimal places. So now let's go to our graphing calculator. Let's actually graph this curve, and let's see if these answers seem to be accurate. Let's verify if our answers are correct. So we will start by graphing our function, which was e to the x power times the quantity x squared plus 3x. Let's go ahead and start with a standard viewing window. So zoom number 6. And there's our function. And then we want to know if we found the correct x values where the tangent line is horizontal. There's a few ways of checking. I'm going to use the drawing menu here above the program key. So go second, draw. Let's go ahead and choose number 5, draw tangent. And then remember, even though it doesn't look like it, the calculator is actually prompting you right here to draw a tangent line at any x value that you want. So you can type in the x value where you want the tangent line drawn. And we want ours drawn at negative 5 plus the square root of 13 divided by 2. So I'm just going to go ahead and type negative 5. I'm going to make sure that I have the numerator in parentheses. So negative 5 plus the square root of 13. The way I'm doing this, I'll have to close those parentheses twice and then divide by 2. Now that it was approximately, we had a decimal approximation for that, remember? And don't put the decimal in here because that won't be as exact. Let's go ahead and put the exact form in. And we'll draw the tangent line. And sure enough, you can see that x value, it was about negative 0.697. But you can see on the graph that that is indeed one of the points on this graph where the tangent line is horizontal. And then you can do it again. So go second, draw again. And I'm actually zoom in. And the minute you zoom in, you change the feature, then the tangent line would have to be drawn again. But you can see this was the point approximately negative 0.69 where the tangent line was horizontal, and it corresponded to a minimum on this graph. Now the other point is at about x equals negative 4.3, which is off of my window here. So either I'm going to go back to a standard viewing window, or if you want to just reset your x minimum, I'm just going to reset mine to be negative 5. Just so that I can see a little bit farther to the left. Then I can see there is a gradual increase here, and then there's a little decrease, so there should be another place here where the tangent line is horizontal. So we'll test that out by drawing the tangent one more time. So draw number 5, and then go ahead and type in negative 5 minus the square root of 13 this time, all divided by 2. And there you can see the tangent line is drawn, and it shows you the little cursor or the bug. That looks like that x value is negative 4.303-ish, and that's where our tangent line is horizontal. And don't be fooled if your calculator is giving you the equation for that tangent line here, this negative 1.1745, but there's an e there. Remember, that is just scientific notation, saying we're multiplying by 10 to the negative 8th power, so we're going to move that decimal 8 times to the left, and that's just the best the calculator can do to estimate the slope, but that is a number very, very close to 0, and that should be the slope of our horizontal line.